Welcome back. We are going to finish up lesson 1 for unit 9, the independent practice. I stopped on number 15 and we are doing number 16. After number 16, even though I said I was going to do number 17, I am going to let you do number 17 and 18 on your own because we went over some of these problems in the guided practice. And I'm just going to do after number 16, number 26, which is a two-column proof. So for number 16, we have parallelogram TVWS, and we have side TV equaling 2A minus 5, and side SW equaling 9A minus 19. Okay, so looking at this problem, remember when I said the opposite sides of a parallelogram are congruent? So if we're trying to solve for A, that means that side TV is congruent to side SW, and we could set them equal to each other. So TV is equal to 2A minus 5, and we're going to set that equal to 9A minus 19. So because we have an equation, we have to get a variable a on one side of the equal sign and the numbers on the other. So I'm going to first subtract 2a to both sides of the equation, and I'm left with negative 5 equals 7a minus 19. Then I'm going to add 19 to both sides of the equal sign, and that's going to give me 14 equals 7a. And finally, we're just going to say 7a equals 14, and we're going to divide by 7. So a equals 14 divided by 7. A equals 2. So that is problem 16 of the independent practice. I am now going to do number 26 and let you do the other couple problems from the independent practice on your own. We've gone over them in the guided practice portion of the video and in these couple independent practice problems. So just make sure you watch the videos. If you have any questions, feel free to call me, email me, text me, or we can talk about it during our Zoom meeting. So let me finish up the last problem of Unit 9, Lesson 1, which is problem number 26. So problem number 26 is a pretty cool problem. It's a two-column proof that wants you to basically determine if these two triangles that are created by a parallelogram are congruent. So here is the parallelogram. We have W, X, Z, and Y, and a diagonal going through the parallelogram. And it says, given, they do this quadrilateral symbol, given basically parallelogram W, X, Y, Z. It says prove that triangle WXZ is congruent to triangle YZX. So as we've talked about in other lessons and the units, the two-column proof has two columns. Your statements, and then it has your reasons. We want to always start with what's given. Essentially, it just says that there's a parallelogram WXY YZ. So I'm just going to say, it's kind of weird, but that's what's given. I just write down what's given. We're just going to say parallelogram XYZ, or that WXYZ is a parallelogram. So this means, I'm just going to put it in parentheses and just write it out. WXYZ is a parallelogram. All right. And the reason is because it's given. And as I've discussed in other problems, we always want to write down at the bottom of the proof. We don't know what number it is, but we want to write down what we're going to prove. So we want to prove that triangle WXZ is congruent to triangle YZX. Okay, that's where we're trying to end up. So the first thing we want to do is figure out the triangles that we want to prove. So we have W, X, Z, and Y, Z, X. And looking at the problem, I wrote this down incorrectly. Z should be at that point, Y should be at that point. So we have W, X, and Z. So this top of the triangle, and then Y, and then Z and X. All right. So the first thing I want to say is like, well, we know that based on the properties of the parallelograms, we're going to determine that these two triangles are congruent. So the first thing I want to do for a parallelogram, we know that the opposite sides of the parallelogram are parallel, and we know that they're congruent. Okay, that's important. So I just want to say that side WZ is congruent, WZ is congruent to XY. And Y is because basically opposite sides of parallelograms are congruent. Okay? All right. Now, what I want to do is we have right here these two angles. We know that they're congruent. So WZX, I'm going to write that down. Angle WZX is congruent. WZX is congruent to YXZ. And that's because alternate interior angles are congruent. Remember the last couple times in the different proofs that we learned from the last units, we have alternate angles right here that are created by a diagonal in a quadrilateral, or if we're looking, because we have looked at parallelograms in Unit 8, basically triangles that are formed from parallelograms just like this. The diagonal creates alternate interior angles. And so these two angles are going to be congruent. So we have a side, an angle, and then what about this diagonal? ZX or XZ. So we know that side ZX is congruent to side ZX. And that's because the reflexive property. So the reflexive property of congruency. And that basically says that a side length is equal to itself. So a side is equal to itself. In this case, a diagonal, ZX, is equal to itself. So I'm going to just erase these parallel lines. And if we look, we have a side, an angle, and a side. So we have proven side, angle, side, that these two triangles, triangle WXZ and triangle YZX, are congruent by side, angle, side. Or SAS, congruency. So that concludes the two-column proof and lesson 1 of Unit 9. Thank you very much for watching this video, and I will definitely post lesson 2 soon. Have a great day.